Computer vision is a branch of artificial intelligence that aims to enable machines to perceive, understand, and interact with the visual world. Computer vision systems use various techniques, such as image processing, machine learning, and deep learning, to analyze and interpret images and videos. Computer vision has many applications, such as face recognition, autonomous driving, medical imaging, and augmented reality. However, computer vision also raises some philosophical questions, such as how do machines acquire knowledge from visual data? What are the limits and sources of their knowledge, and how do they justify their beliefs and actions based on their knowledge? These questions belong to the domain of epistemology, which is the study of knowledge and its nature, origin, and validity. We will explore some of the connections between computer vision in AI and Kantian epistemology, which is the epistemological theory developed by the 18th-century German philosopher Immanuel Kant. Kant's epistemology is based on his distinction between two kinds of judgments, analytic and synthetic. Analytic judgments are those that are true by virtue of the meaning of their terms, such as, all bachelors are unmarried. Synthetic judgments are those that are not true by virtue of their meaning, but by virtue of their relation to the world, such as, all bachelors are happy. Kant argues that most of our knowledge consists of synthetic judgments, especially those that are based on experience. However, Kant also claims that there are some synthetic judgments that are not based on experience, but are a priori, meaning that they are known independently of experience. These are called synthetic a priori judgments, and they include mathematical truths, such as 7 plus 5 is equal to 12, and metaphysical truths, such as every effect has a cause. Kant argues that these judgments are possible because they are derived from the pure forms of our intuition and understanding, which he calls the transcendental aesthetic and the transcendental logic. The transcendental aesthetic is the part of Kant's epistemology that deals with the forms of our intuition, which are space and time. Kant argues that space and time are not properties of things in themselves, but subjective conditions of our perception. We perceive objects as existing in space and time because we impose these forms on them through our intuition. Therefore, space and time are a priori forms of sensibility that make possible synthetic a priori judgments in geometry and arithmetic. The transcendental logic is the part of Kant's epistemology that deals with the forms of our understanding, which are the categories. The categories are the basic concepts that we use to think about objects, such as substance, causality, quantity, quality, etc. Kant argues that the categories are not derived from experience, but are innate structures of our mind that we apply to experience. Therefore, the categories are a priori forms of thought that make possible synthetic a priori judgments in physics and metaphysics. Kant's epistemology is thus based on his idea that human knowledge is constructed by the interaction between our sensibility and our understanding. We perceive objects through our sensibility according to the forms of space and time, and we think about objects through our understanding according to the categories. However, Kant also maintains that we can never know things in themselves, noumena, but only appearances, phenomena, which are the result of our cognitive faculties. Therefore, Kant's epistemology is both constructivist and transcendental. Computer vision in AI can be seen as an attempt to emulate or enhance human vision using machines. Computer vision systems use various methods to acquire, process, analyze, and understand visual data from images or videos. Some of these methods include 1. Image processing. This involves applying mathematical operations to images to enhance their quality or extract useful information from them. For example, image processing techniques can be used to remove noise, sharpen edges, adjust contrast or brightness. 2. Machine learning. This involves using algorithms to learn patterns or features from data without explicit programming. 3. Deep learning. This involves using neural networks to learn complex representations or functions from data using multiple layers of processing units. Computer vision systems can perform various tasks based on their visual data analysis, such as 1. Object detection. This involves identifying and locating objects in an image or video. 2. Face recognition. This involves identifying or verifying a person's identity based on their facial features. 3. Scene understanding. This involves inferring the context or meaning of an image or video based on its content. Computer vision systems can also interact with other systems or agents based on their visual data analysis, such as 1. Autonomous driving. This involves controlling a vehicle's movement and behavior based on its perception of the road and traffic conditions. 2. Augmented reality. This involves overlaying virtual elements or information on the real world based on the user's perspective and location. There are some interesting connections between Kantian epistemology and computer vision in AI, both in terms of similarities and differences. Some of these connections are: 1. Both Kantian epistemology and computer vision in AI involve the construction of knowledge from visual data. However, while Kantian epistemology focuses on the subjective conditions of human perception and cognition, computer vision in AI focuses on the objective methods and algorithms of machine perception and cognition. 2. Both Kantian epistemology and computer vision in AI involve the use of forms or structures to organize visual data. However, while Kantian epistemology posits a priori forms of intuition, space and time, and understanding, categories, that are innate to the human mind, computer vision in AI uses learned or designed forms of representation, features or models, that are specific to the machine or task. 3. Both Kantian epistemology and computer vision in AI involve the distinction between appearance and reality. However, while Kantian epistemology claims that we can never know things in themselves, but only appearances that are shaped by our cognitive faculties, computer vision in AI aims to approximate or reconstruct things in themselves, or at least their relevant properties, from appearances that are captured by sensors or cameras. 4. Both Kantian epistemology and computer vision in AI involve the possibility of synthetic a priori judgments. However, while Kantian epistemology argues that synthetic a priori judgments are possible, because they are derived from the pure forms of our intuition and understanding, computer vision in AI argues that synthetic a priori judgments are possible because they are derived from the statistical regularities, or causal relations of the data. We have explored some of the connections between Kantian epistemology and computer vision in AI. We have seen that there are some similarities and differences between the two fields, both in terms of their goals and methods. We have also seen that there are some philosophical challenges and opportunities for both fields, such as the question of how to justify or evaluate their knowledge claims, or how to balance their performance and efficiency.